For this topic, I'll be looking into the Avogadro's constant as well as the Avogadro's constant calculations to calculate the number of atoms or particles. This is the definition of the word 1 mole. 1 mole refers to how many particles there are, or how many atoms there are, or how many ions there are, and it's a fixed number. If they ask you to define the term 1 mole, you write this number there, which is the Avogadro's constant. If you wanted to rearrange that to get the number of atoms or the particles which something has, you take the moles of that substance, multiply it by the Avogadro's constant. Let me give you two examples. First example says, calculate the atoms in 0.2 moles of sodium. So you simply take your moles, which is going to be 0.2, you multiply it by the Avogadro's constant. In this case, it's going to be the 6.023 times 10 to the power of 23. Notice how I use the brackets. I write my equal sign, and if I did that on my calculator, I do 6.023, 6.0223 times 10 to the power of 23. I store it, and I multiply that by the 0.2. Multiply that by 0.2. I get the final answer to be 1.2046 times 10 to the power of 23 atoms. Now, if I want to work it out for how many ions of sodium there are in sodium sulfate, notice that there are 2 times. So what you actually would have to do there is, because there's 2 times the Na plus in the Na2, you actually do 0.2, which is the moles, and there's 2 of them, so you do 0.2 times that by 2, which is 0.4. Once I've got the 0.4, then again, all I need to do for that particular question is I take the 0.4, multiply it by Avogadro's constant, 6.023 times 10 to the power of 23, and I get my final answer, which is going to be 6.023 times 10 to the power of 23. And if I multiply that by 0.4, I'll get my final answer to be 2.4092 times 10 to the power of 23 ions of sodium.